So today we'll be learning about the limitations of the first law of thermodynamics and in how it helped in the second law of thermodynamics.
Okay.
So talking about the limitations, okay. First of all, we have to know what is first law. Okay. This is the definition of the first law that it is about law of conservation of energy. Okay.
Okay.
So energy cannot be created, cannot be destroyed. It can only be transferred from one form to the another. Another way, we can say that the total energy of an isolated system is always constant.
Always constant.
Correct.
Yes, sir.
So this is the first law. Now it looks very simple. It just talks about the conservation of energy. Now what about the limitations? What this law fails to talk about is, first of all, it does not talk about direction of flow of energy. Now
Okay.
take this cup of coffee for example. Now if you keep this cup of coffee at room temperature, what will happen? This hot cup of coffee. Suppose a hot cup of coffee you have kept at room temperature. What will happen is that it will start cooling,
Cooling, right.
right?
Yes, sir.
So it will lose energy. So in other words, we can say that the heat from the coffee will flow out to the atmosphere.
Yes, sir. Yes, sir.
Okay, that's why it start cooling. That means the heat is flowing from the coffee towards the atmosphere. And what will happen if it goes the other way? Can the heat flow from the atmosphere towards the hot cup of coffee? Can it go back? Right. So according to first law, it can, because first law only states that energy is conserved.
Okay. Yeah. Yes. Energy changes in one form to another form.
Right. It does not talk about the energy will flow from hot to cold or cold to hot. Okay. It does not talk
Yes.
about that. It only talks about conservation of energy. But in real world, we know that it's not like that. There must be a direction of flow of energy. There must be something which defines that the energy will flow from this body to this body. But the first law fails to do that. Okay.
Okay.
So let's talk about the second limitation. Now, the second limitation is also that the first law does not talk about spontaneity of process. So, what is spontaneity? Spontaneity or feasibility is only the same thing. It means that whether a process is going to happen on its own or not.
Okay.
For example, melting of ice. If you keep ice
It's
outside,
happen. It's on.
what will happen? It will start melting. Okay,
Right.
it's
Yes.
it will start melting on its own. What about diffusion of gas? If you spray a perfume in a room, it spreads throughout the room,
All over
right?
the room.
All over the room, right? Evaporation of water also happens in the same way. Dissolution of salt also happens in the same way. It means that all these processes are happening on their own, hence they are spontaneous. But according to the first law, we cannot predict the spontaneity. How? First law only talks about energy conservation. So according to first law, when ice is melting and it's converting into water, that means it is losing heat,
Energy transfer from another form.
right? But according to first law, the reverse can also happen. The ice, the
Yes.
water which is kept normal temperature, it can come back and form ice also. But it does not happen, right?
Right. Yes, sir.
Can a gas which is diffused, can it come back on its own to some point?
No.
Can this spray which is coming out of
It's
this,
happened, but external force are required.
right? Correct. So it cannot go like this, right? It cannot go back to the this perfume can on its own. Okay. This is spontaneity. Spontaneity means happening on its own. So the reverse thing cannot happen on its own. So again, the
Okay.
first law fails to understand this. First law fails to explain this to us.
Okay.
Okay. So therefore, we need a law which can explain these two things, and that law is your
Second law of
second
thermodynamics.
second law of thermodynamics. Now, second law of thermodynamics will help us to determine first the direction of energy, and also helps
Right.
us to determine whether a process can be spontaneous or not. How it does that? Very simple definition. Second law states that spontaneous processes are irreversible process, and they are accompanied by increase in the disorderness or randomness.
Random.
This is the keyword, disorderness or randomness. So it says that whenever disorderness increases or randomness increases, a process will be spontaneous. Now, what is randomness? Or what is disorderness? We have to measure it somehow. So to measure this randomness and to measure this disorderness, we have a mathematical function. What is this function called? It's called entropy. Now, entropy is a state function, and its numerical value is heat released or absorbed per unit temperature. Okay, and temperature should always be in the
Kelvin.
Kelvin state. So this is how we'll measure entropy. And once we measure entropy, we can find whether entropy is increasing or decreasing.
Decreasing
And according to that, we can predict whether a process can happen or
or not happen.
not happen. Correct? Understood?
Yeah.
Okay.